Okay, example number 3 here, talking about the fundamental counting principle, which again, if you scroll back up, uses multiplication, I'll even go as far as to highlight that, to calculate the total number of outcomes. So, the state of Ohio has license plates that use 6 characters. So 6 characters is jumping out at me. These characters are ordered with 2 letters of the alphabet, and then 2 letters, 2 numbers between 0 and 9, and then 2 more letters. So I just like to color code 2 numbers. No, I wanted that, not that color. Pink. 2 numbers. Okay, so how many different license plates are possible? Which we know has to be a ridiculous amount, because if you're talking about the number of people in Ohio and how many different license plates need to be able to be generated, that's a whole bunch of people. All right, so first thing I'm recognizing was, again, that there's 6 characters to these license plates. So I'm just going to start with 6 spaces. Kind of like when I was doing the ordering the people. 1, 2, 3, 4, 5, 6. Awesome. So then we go on to know that they are in order with 2 letters of the alphabet. So I know that these first 2 have to be letters. Then 2 numbers between 0 and 9, which I'll get to in a sec. And then 2 more letters. Again, the more you color code, the better. I don't know. I think it helps stick in the brain. And then, oh, you know what? We should do pink. I'm sitting here talking about color code and I'm not following my rules. And so 2 numbers. Okay. So my first spot has to be filled with a letter. Well, in order to figure out how many possible choices I have for a letter, you need to know a key fact of how many letters there are in the alphabet. So if you don't know that off the top of your head, I would very much make sure that you have a bunch of stars where you can find this piece of information. It is my pleasure, and also, hey, I know every single one of you knows your ABCs, so worst case scenario, if you did not know the total number, take the 4D seconds it takes to write out your entire alphabet and count the numbers. Not awful. But so anyways, doing that, you will learn that there are 26 total letters in our English alphabet. So super important piece of information. So that means for this first spot here, I have a choice of 26 possible letters. I can use an A, B, a C, or D, or blah, 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 blah. So then the second letter space, I also have 26 possible choices, because nowhere in this problem did it tell me if I could or could not repeat letters. So I'm just going to assume that I can, right? License plates can have the same letter in them multiple times. Which then means I could actually go ahead and fill in these 2 letters with 26 as well, because I know that I have 26 total letter choices. Now, up next, we have to talk about the numbers that are between 0 and 9. Maybe you're immediately thinking that we need to be plugging 9s in here, and if you're doing so, you are making a slight mistake. Numbers 0 through 9, if I were to actually take a hot second and list them out, these are the kind of skills, test-taking skills, that prevent you from making mistakes. You'll realize that I don't have 9 choices. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because of that 0. So 10 possible choices for numbers, and then 10 possible choices for numbers again. Now, for the license plate, am I picking a letter, or a number, or a number, or a letter? No, it's and, because that's the name of the game, and because the fundamental counting principle tells us to be using multiplication here. So, mathing that into your calculator, 26 times 26 times 10 times 10 times 26 times 26 is going to be something obscenely large. First, I'm going to need to scooch this out of the way. And we have a total of 5,697,600. Woof! Possible license plates. Which makes sense because there's quite a few people in the state of Ohio, so there has to be that many possible outcomes. And I just wanted to kind of solidify this, that this is 10 options.